Hello everyone, my name is Summer Ragsdale, and this is Life on Blasse, Episode 1. Blasse is named for the German word for pale. It is almost a carbon copy of Earth, except for a few small things. Its gravity is 1.5 times stronger, which makes the atmosphere much denser. This will allow for larger storms and flying creatures than on Earth, in a hotter climate. Land creatures will be smaller on average, excluding a few species with unique adaptations to manage their own body weight and gravity. Snow will be very rare for a long time on Blasse. The thick atmosphere will keep life here toasty for a long time, but the ice will come, one day. Blasse sits comfortably in the center of the habitable zone and has a moon slightly closer than our own, causing larger tides and brighter moonlit nights. The first macroscopic creature to evolve is Triantical Limax. It is a small, planktonic animal that eats microbial life and any detritus that floats past its 3 tentacles. It has a hard shell, which holds its body together and protects against collisions and high currents that could rip its body apart. The shell will prove to be a great example of exaptation in the future. It has a very simple blind gut and 6 spiracles with which it diffuses gas. A novelty of this creature is that it contains small pockets of fat which provide buoyancy and store energy for long periods without food. Because of this, a starving Limax will float in the middle of the water column rather than at the surface. Limax are asexual and have no defined genders. Not long after Triantical Limax's evolution comes Parentequa pila. The white patches on its body are photosynthetic organs. Despite the inefficient color, the first and only form of chlorophyll to evolve on Blasse contains white pigmentation. It is not known exactly what makes them white, but the molecule that pigments the leaves is integral to the shape of the chlorophyll. It too is a floating plankton on the surface of the ocean. While some species can grow more, the most developed and abundant species contain only 8 strong tentacles. These absorb small microbes that happen to brush against them and provide sustenance during times when photosynthesis isn't as viable. The lower black portions of its body are heavier, so these creatures can't flip over as easily. If they were to get stuck upside down, they would starve and their leaves would rot, leaving behind an empty, black, floating husk. These 2 life forms will become the ancestral body plans for all biological life on Blasse. Now let's take a look at their descendants. Triantical globulos evolved a thicker shell, allowing it to live nearer the shore where algae and plankton are more common. It widened its mouth and developed small branching hairs on its tentacles to catch more prey. Its fatty deposits have evolved and grown larger compared to the rest of its body to help keep it afloat, even when the creature is starving. When the fat deposits are empty, they fill up with air produced during digestion. These air sacs can act like the bumpers on a bumper car, protecting the animal by letting it bounce off hard structures instead of slamming hard into them. Parentequa album is an obligate autotroph. Its ancestors' 4 photosynthetic organs have fused and become one large leaf. Its tentacles have lost the ability to consume small microbes and are now rigid, absorbing minerals from the water and substrate. Its black lower body performs similar to the basal disc of anemones, sticking to rocks and allowing it to leave a non-favorable area. The rest of its body is dense to allow it to naturally sink after each jump. Parentequa venenum evolved from a Parentequa pila species with more than 8 tentacles. It's lost its photosynthetic organs in favor of a more active, filter-feeding lifestyle. The larger tentacles are mildly venomous, not capable of giving more than a rash to or me, but lethal to the small life of Blasse. Its smaller tentacles are coated in digestive enzymes, which grab stunned prey and begin digesting them. The most common place to find these familiar-looking creatures is at the water's surface, dangling their tentacles down in hopes of catching large macroscopic prey. These traits will make Parentequa venenum the first predator on Blasse. Tripilovermis left the competitive and quite frankly overpopulated surface and became a sessile organism. It sits on the seafloor using its balls to catch and eat prey, reminiscent of the ping-pong ball sea sponge of Earth. The balls are actually inside-out stomachs. Its ancestor's shell has become a sort of anchor-like foot, which holds it to the seafloor. Vermis species tend to fare better on rocky substrates, and so, as the years pass, rocky reefs full of the species will develop. These reefs will be the home for many unique creatures. Colonium brachiorum is a colonial species of Parentequa venenum that sticks to the rocky seafloor in the vermis reefs. They were fortunate to evolve during the time where life was beginning its migration to the seafloor. It's the first life form on Blasse to exhibit sexual reproduction. Males disperse the genetics for the body, while the females disperse the genetics for the mouth and stomach. If a female gamete doesn't meet a male gamete, it will slowly be torn apart by the waves as it grows. If a male gamete doesn't meet a female gamete, it will starve. Upon contact, the two gametes will fuse and form a new Colonium brachiorum colony. They can reproduce through fragmentation as well, as long as the body and mouth parts survive the break together. Trienticle pinguis is specialized even farther into its fatty deposits, now using them as ballasts to control its descent and ascent. If it detects the smell of a harmful chemical or toxin, or if a storm is too dangerous, it can rapidly descend by venting its preserved fat, and replacing it with seawater. After a harsh descent, this animal will kick its metabolism into overdrive to produce gases that will let it float back to the surface. Pinguis internalized its ancestors' tentacles and made its mouth into a siphon. This creates a more active feeding style and creates less drag when they float or sink. Attached to its two frontmost spiracles are chemoreceptive glands and a dense clump of nerves. These two organs heighten its sense of smell and allow it to memorize different scents which may indicate food or danger. All pinguis are born with the instinctual knowledge of what glucose and parentequa venenum smell like. Capreolus album has a similar shape to earth mushrooms. As the vermis and brachiorum reefs expand, these plants are forced to move away from the rocky areas. The substrate of the ocean has become very loose, as it's made of trienticle shells and marine snow. 4 of its tentacles will have to develop into anchor-like structures to hold it in place, among the loose silt and detritus. The other 4 tentacles sit in the water and absorb minerals and nutrients. The lower 4 tentacles have thickened skin and can no longer absorb anything. Their photosynthetic organ has split into 2 tiers and widened much more to starve competition that gets too close and to absorb more sunlight. Album forest will encircle the edges of vermis reefs, but only ever on the deeper side. No macroscopic animals have been brave enough or strong enough to survive the shore and the tide pools, but that will change very soon. These 9 creatures will be the foundations of all life on Blasse, and their descendants will become varied and so diverse you wouldn't believe they had a common ancestor. In the next episode, we will discuss the first true predators of Blasse and how life will adapt to them.